Okay, this video is probably going to be a little bit longer than normal, so pause and take notes as appropriate. Here's your original function, which is a rational function, polynomial divided by another polynomial. Here it is in factored form. This tells you that we have roots at -1, 0, and -2, 0. That's when the function has a value of 0 at those two x values. And it has a vertical asymptote at x equals 4, because you can't divide by 0. Now we can use the first derivative to find out where we have intervals of increase and decrease and where we have relative mins and maxes. So we're going to use the quotient rule, denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. And if you use FOIL, remove parentheses, combine similar terms, this is what you get. So we want to know, when does the first derivative equal 0? And that's kind of what I've done over here by completing the square as opposed to using the quadratic formula. I moved this -14 to the right side, completed the square with a +16, and there are the values for which the first derivative equals 0, 4 minus the square root of 30 and 4 plus the square root of 30, which are approximately -1.5 and 9.5 respectively. So here's the first derivative test. Another critical number is 4, a value that where the first derivative is undefined, and I like to mark that with a little X on this number line, and even consider drawing a dashed vertical line to indicate that's where the vertical asymptote is. But then here's the critical numbers, about -1.5, about -9.5, and over here I've done some scrap work to pick test numbers in each interval. So for example, f prime of -2, I've proved to myself is a positive number. The denominator, by the way, of f double prime is always positive because of this exponent of 2. And so that means the original function, whoops, this should not have an f prime there. The original function is increasing everywhere to the left of -1.5. And f prime of, I could have used 0, is negative, so decreasing. That means increasing to decreasing, we have a relative minimum, a relative, actually I got this backwards. This is a max, and this is a min, because we went from decreasing to increasing. So keep those in mind as we have to answer this question right here. Maximum value of y equals what when x equals what? But let's go to the second board and look at the second derivative test. The second derivative test. So here's f prime again, denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. Well, we have to use the power rule followed by the chain rule, but the derivative of the inside is 1 over the denominator squared. Now, instead of multiplying this all together, check this out. There's a common factor of x minus 4 in both terms on either side of this minus sign. And this 2x minus 8 can be written as 2 times the quantity x minus 4. So we can factor out a 2 also. And that's what I've done here. I've pulled a 2 and an x minus 4 out of each term in the numerator. From this first term, there'll be x minus 4 times x minus 4 left over. And I factored out these two factors. So I'll be taking the opposite of x squared and get a minus x squared plus 8x plus 14. Combining similar terms after multiplying these two together gives us this. So this second derivative is never equal to 0. It's undefined at x equals 4. That's that horizontal asymptote again. So to the left of 4, this denominator will become negative, like if I put a 3 in here. So that tells us that the original function is concave downward to the left of 4 and concave upward to the right of 4. But there is no point of inflection because the concavity changes at 4, but that's undefined even for the original function. Okay, now nowhere does the problem suggest that you graph this function, but there's the y-intercept. When I put 0 in for x, I get 2 over negative 4, negative 1/2. There are the roots again. Vertical asymptote at x equals 4. End behavior up, up as x goes to infinity. The numerator is 0. Oh, it should be up, down, sorry. As x approaches negative infinity, the y value goes towards negative infinity also. So I'm sorry, it's down, up. To the left, approaches negative infinity. To the right, approaches positive infinity. So here's how you find the slant asymptote. We want to rewrite the function by using long polynomial division. We get x minus 4 divided into here. It gives us x plus 7 with a remainder of 30. So I can rewrite the function like this. It's the same function. But as x approaches infinity, this term is positive, which means the graph, a point on the graph of the function will be above its slant asymptote. And this is the slant asymptote right here, y equals x plus 7. And I've sketched that slant asymptote right here, y-intercept of 7, slope of 1, and here's the vertical asymptote, x equals 4. So the graph cannot cross either of those blue dashed lines. And since we say the graph is above its horizontal slant asymptote because this term is positive, as x approaches infinity, that means it has to be above this dashed line. But as x approaches 4 from the right, putting that in here, we're going to get 32 over very small numbers like 4.001. And that's going to be positive infinity. So that's how we get this graph right here. And we could do similar reasoning for this graph right here, but also by plotting the roots and the y-intercept. That also tells you that the graph has to be in this region right here. If I go to board 4, there's a graph from Desmos. Here's what's happening in here. Expand it over here, or focused in. There is your relative maximum right there. This is a 4 minus the square root of 30. If I put that into the function, 4 minus the square root of 30, I get about 0.046, barely above the x-axis, but that's your relative minimum. And over here, tangent line has a slope of 0. There's your 4 plus the square root of 30. There's the y value, 21.954 approximately. Okay, and you could put 4 minus the square root of 30 into that f of x and simplify and get an exact value in terms of the square root of 30. I won't do that here, but there you go. Hope that helped. If you have any questions, post a comment.